Welcome back to Paideia classes. In today's continuation of our subset series, we will explore how intervals on the real number line act as subsets. Now get ready to uncover some mind-bending concept in your math journey. So far, we have explored various subsets like 1, 2, 3. Now, which one would be the subset? 1, 2, 3. The set 1, 2, 3 would be subset of 1, 2, 3, 4. Why? Because each element of this set is also an element of this set, right? Similarly, we have even seen the example of subsets for infinite sets also, like n, 1, 2, 3, and so on, and the set of integers, which consist of positive, negative, and zero numbers. So -3, -2, -1, 0, 1, 2, 3, and so on. So it contains all the natural number, and therefore natural number is the subset of R, the integers. Now see, this is an infinite set. This is also an infinite set. We kind of know how this set works. Like we know what is the next number. We always, when you have one number, suppose you have 50 lakhs, right? Even if you have 50 lakh, you know that what would be the next number. You simply need to add just one number and you will get the next number. And same goes for this also. We know what is the previous member of this set or what is the next number of this set. Same goes for these two sets. And it is kind of like we can measure the element of this set. Like we know that this is the set consists of infinite number of elements. But still we know these sets. We know it like by heart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Same goes for integers also. This type of sets, which even though they consist of infinite number of elements, but kind of we can measure. They call countable sets. Countable sets. They are infinite and countable. But there are sets, we have discussed the set of real numbers, R, which consists so many elements that it is not exactly possible to measure them. They have so many numbers that we cannot count and we cannot even think to count these elements. And they call the uncountable sets. It's a very vast theory, but I just give you a little bit of the picture of this thing, uncountable and countable sets. So this line, we call it real number line. This line consists of all the real numbers. It consists of all the natural number, integers, rational number, and irrational number. Each point on this line represents a number. And between any 2 points on this line, there are uncountable elements or uncountable real number. Consist of both rational and irrational numbers. There is no number which is next to some number. You cannot define it like that. There is no number which you can define that, okay, this is the next number or this is the previous number. You cannot handle this. You cannot even handle the number of elements that comes between these 2 points. But we know if we have a number, we would know, okay, if this number belongs to this line or not. we would know that if this number is a real number, whatever number it is, root 2, root 3, root 4, we would know that this number belongs to this line. We may not be able to locate it on a very precise location, but we would know the approximate position of the number. So each and every point on this number line represent a real number, and this line consists all the real number that comes between minus infinity and infinity. And even between two numbers, even between 2 points, there are infinite numbers, not just infinite, there are uncountable numbers between any 2 points. Now, with this much of number, still we can discuss the concept of subsets. And for that, let's first see what are intervals. What does we mean by intervals of R? So suppose this is your number line. This is 0. Suppose this is 1, this is 2, this is 3. This is -1, this is -2, this is -3. Now between these numbers, you have half. Then root 2 is equal to 1.414 something. So it would be somewhere around here, right? So there are different numbers. Now all the elements that comes between 1 and 2, we can name them as interval 1, 2. And there are different type of intervals. Suppose, let's talk about open interval. Let A and B are two real numbers. It could be anything. It could be positive, negative, whatever. They are just simply two real numbers, and A is less than B. So, if we want to locate this on a number line, you can take any two numbers. We don't know which one is which. But A is less than B, so A should be left to the B. Like 1 is less than 2, so 1 is left to the 2. -1 is less than 0, so it is left to the 2. So that's how we know that A is less than B and it is left to the B. And if we defined a set like this, Y such that this set contains all the elements which comes between A and B. Now we have seen this type of sets before for the natural number. Suppose for natural number, suppose we have this. And here, even though in your book it is not written, you should also write that Y belongs to Y. That Y is a real number such that Y comes between A and B. So suppose for natural number, we have learned this type of sets that X is a natural number such that X comes between 4 and 1. And in tabular form, we know that this set is 2, 3. Right? We can write all the elements. We can list all the elements in this set. Now, when we are talking about this real number, we have any 2 points A, B, any 2 points or any 2 real numbers, they are the same thing. So, any 2 real numbers A and B, and all the elements that comes between these 2 numbers forms a set. And if no element is equal to A or B, we say that this interval is open, meaning there is nothing to close over here. So, Now, this is a well-defined because if you have any number, or not just number, if you have anything, you can tell whether this comes between A or B or not, because you would know if it is greater than or not. So for example, suppose for the if you want to, so this is called open interval AB. Now, if I want to write open interval 1, 2, how would I write? I will write Y belongs to R, so Y is a real number such that Y comes between 1 and 2. Now, for this is a well-defined set because if you have half, you know that half does not belongs to open interval 1, 2. Why? Because it does not come between 1 and 2. Half comes around here. It does not come between 1 and 2. And similarly, if you have 3, you know that 3 does not come between 1 and 2. So 3 does not belongs to 1 and 2. If you have 1.5, you know that 1.5 belongs to 1 and 2 because it is somewhere around here. It comes between 1 and 2. So we know that if we have any real number, we would know that if it is greater than 1 and less than 2 or not. And that is why this set is well defined. There is no confusion that if any element belongs to this set or not. So all the real numbers which come between 1 and 2. Now, if you just change this a little bit and you simply just include your endpoints. What does endpoint? These two things. So Y is a real number such that Y is greater than or equal to 1 and less than or less than or equal to 2. We would say this set is a closed interval. So all the elements that comes between 1 and 2 and also 1 and 2 are included. We are including 1 and 2 also. This is called closed interval. So this we were calling open because we were not taking 1 and 2. So it was open from both sides. Then we closed both the ends and we include our 1 and 2. Now there are two more situations that we can do. Like we can open it from 1 and close it from 2, or we can close it from one side and close it to 2. So these type of interval we call them semi open or semi closed. So there's simply nothing. You can refer any of these two terms. They are what? You can take this interval where you can take all the real numbers which are greater than or equal to 2, sorry, A and less than B. So here we are taking 1 and 2. So you can take all the intervals which are greater than and equal to 1 and less than 2. So we are including 1, but we are not including 2. We can do one more thing, which is we can include 2 and we do not include 1. So Y, all the real numbers such that 1 is less than Y or Y is less than or equal to 2. 1 is greater than Y. Sorry, I mean to say 1 is less than Y and Y is less than or equal to 2. So this interval, we call this interval open in this is an open interval 1, 2 including 1 but excluding 2, and this is open interval 1, 2 including 2 but excluding. Now we understand what are intervals of. So if we have A, B, what does this consist of? This consists of all the real number that comes between A and B, and A and B both are excluded. So in real number line, if this is A and this is B and A is less than B, the condition is that A is less than the element which you are writing over here should be less than this element. So A is less than B. All the elements that comes between A and B, and we are excluding both A and B. Second type of interval is closed interval. This consists of all the real numbers such that A is less than or equal to Y and Y is less than or equal to B. It means that this consists all the elements that comes between A and B, and we are also including our A and B both. Then there are two more type of interval, AB and AB. All the real numbers which comes between A and B, and we are including this B and excluding A. So this sign is open, this sign is for open, and this sign is for closed. So whichever direction this sign would be, that element would be included, and whichever direction this side would be, that element would be excluded. So here both sides were open, that's why neither A nor B were included. Here both to the both side we have this closed symbol, so both A and B are included, and here we are open from this A and closed from B, so that's why we are excluding A and including B. Next, we have all the real numbers such that they comes between A and B, and we are including now A and excluding B. Why? Because A, from the end A we have closed sign, and from the end B we have open sign. So on number 9, for this third set, we have elements, all the elements that comes between A and B, and we are including B but excluding A. And for the fourth one, all the elements that comes between A and B, and we are including A. So we are including A but excluding B. Let's see some example. If we have 1, 2, what does this mean? This means all the real number, and we are talking about in the context of real number. All the real numbers such that which comes between 1 and 2. All the real numbers, all the irrational that comes between 1 and 2. If we have closed interval 3, 4, it means all the real numbers that come between 3 and 4, and 3 is also in the set, 4 is also in the set. If we have this 5, 6, now all the real numbers that comes between 5 and 6, but since it was closed from 6, and 6 would be in the set, but 5 would not be in the set. So 5 does not belongs to this set, and 6 belongs to this set. So now we understand what does interval means. Now let's see them in the context of intervals as subsets of real. Okay. So suppose this is the real line. This is minus infinity, plus infinity. Okay. Before that, just quickly one more thing. The real line, we can represent it as minus infinity, infinity, open interval, minus infinity, infinity. So all the real numbers that comes between these two things, minus infinity and infinity, would become in this set, and we will call them real. Okay. Suppose we have 2 points, A and B. Now let's take two more points, C and D. If we look and let's discuss two intervals, CD and AB. We can take open, close, semi-open, semi-close, whatever. Let's take open. Let's write. So AB is what? AB is what? All the real numbers that comes between A and B. And CD is what? All the real numbers that comes between C and D. So if you look closely, this is, let's name them also. This is set A and this is set B. This is how we represent our set till now, right? Set A and set B. So set A is what? All the real numbers that comes between A and B, and set B is what? All the real numbers that come between C and D. So this is our set A, right? And this is our set B. So this means this. All the numbers that comes between A and B, right? This means all, this is what represents this set A. All the numbers that comes between A and B. And all the numbers that comes between C and D, they would represent the set D. So if you can see that all the elements A and B, all the elements that are between A and B are also the elements that comes between C and D. What I am saying is all the elements that comes between A and B, A and B, meaning elements of set A, right? Are also comes between C and D. Whatever element, this is between A and B, but this is also between C and B. This is between A and B, but this is also between C and B. So, what is this? This is elements of B. It means that all the elements of set A are also the element of set B. And when we get this, what does this mean? If every element of A is also an element of B, this would mean that A is a subset of B, right? So, all the elements of our set A are the element of set B. So, it means that this set A is a subset of B. Or AB, the interval, open interval AB is the subset of open interval CD. Right? In fact, closed interval AB is also subset of open interval, closed interval CD. So, let's see them. Let's understand this with the help of an example. So, it will be more clear to you. Suppose we have this number 9 and we can choose any two numbers. Let's take simple -1 and 1. Okay. Let's take these two interval and make this interval -1. And let's take another interval and we need to take a number which is less than -1. So let's take -3 and let's take this as 5. So we have interval minus 3 and 5, and we can close it, open it, whatever, doesn't matter here. Simple, the definition should follow that all the elements of set A should be the element of set B. Okay. So what is minus 1, 1? What does minus 1, 1 represent? It means all the real numbers that comes between minus 1 and 1. And neither minus 1 belongs to this set nor 1 belongs to set. Let's name this set C. Now let's name this set D and write it as all the real numbers such that all the real numbers that come between minus 3 and 5, and here since it is closed with from minus 3 side, we will include minus and we will exclude 5. So basically this set, right? So the set A, which we have represented it by red pen, and set, not set A, set C. So set C, we have represented the elements of set C on number line with the red pen, and set D, we have represented it with the help of green highlight. We can see that all the elements of set C are also the element of set D, which is the definition of set. So what does this mean? This means that C is a subset of D. So for any interval, now if we have any interval, we can tell whether or not they are subset of each other. So if we have 1, 2 and let's say 0 or 3, we know that this 1, 2 is a subset of this 0, 3, because all the elements of 1, 2 belongs to 0. Basically for the left end, the bigger set should be less than, the right hand should be bigger. So whatever points we have A, B, C, D, we know that A, B is a subset of C, D. Right. Now all intervals are subset of real number R. All intervals are subset of R. Why? Because obviously you have this number line, right? You have this number line. So minus infinity, plus infinity. All the elements are real numbers. So whatever interval you would take, it would be in the set minus infinity. All the intervals are subset of minus infinity, infinity. Okay. If you have 1, 2, suppose you have this 1, 2, and you have let's say 1.5 and 3. Now 1, 2 is what? 1, 2 is this set. 1, 2 is this set, and suppose this point is 1.5. Then 1.5 to 3 would be what? This set. 1.5 to 3 would be this set. So obviously not all the elements of 1, 2 are the elements of this 1.3, 1.5 and 3. Like 1.2 does not belong to 1.53. So it is not a subset of this interval. So basically your interval should be properly contained into the bigger interval. Then it will be subsets of that interval. And all intervals are subset of your real number, because they are properly contained in your minus, you can take any interval. Now, let's talk about universal set. What is universal set? What does universal set? What does universe mean? In general, have you ever think what is universe? What does universe mean? Universe generally refers to everything that exists. Everything that exists. Everything that your space, your time, your matter, your energy, everything, whatever you can think of, everything exists in universe. It exists in universe. Everything. In the context of our set theory, when saying universal set in a set theory, what does it mean? It basically refers to a set. It basically refers to a set that contains all the elements under consideration. For example, in our previous whatever we have discussed till now in this video, we can take R as a universal set, and yeah, it is denoted by U. It is denoted by. So, in our previous context, the universal set is R. So, for example, if we are talking about natural number and we are dealing with different set 1, 2, 3, 4, 5, 6, whatever, we can take N as our universal. We can also take integers as our universal set if you are talking about if there is more elements involved. So, universal set is basically contains all the element under consideration. Okay, let's wrap this lecture over here. And in the next lecture, in the next video, we will solve our exercise 1.3. If you have any query, please write that in comment section. If you have any suggestion, please write that also in comment section. And if you found this lesson helpful, please don't forget to like, share, and subscribe. And I try to explain everything. But still, if you have any doubt, please ask. Okay, so keep exploring, keep learning, and see you in the next video. Thank you for watching.